Hello, my name is Andrew Severin, and I will be presenting an introduction to Unix. This tutorial will cover the introduction, getting started, file creation and editing, viewing file contents, renaming, copying, deleting files and directories, counting, sorting, and redirecting output, finding and replacing content, downloading and transferring data, the Unix manual pages or help pages, and soft links. The introduction. What is Unix? Unix is a multi-user operating system. You can think of it similar to your Windows operating system or a Macintosh's iOS operating system. Linux is the free version of the Unix operating system. Some examples include the Red Hat Enterprise Linux, Ubuntu, and CentOS. It's used on high-end workstations, database servers, web servers, and is used to manage shared resources. Standard features include increased security, reliability, scalability. For example, it can support hundreds of users at the same time. I often get the question, can I learn Unix? How hard is it? And the answer is yes, absolutely you can learn Unix. It's just another operating system. It's just another way of interacting with a computer. It really is no more difficult than learning Word, Excel, or PowerPoint for the first time. The biggest difference is that in Linux, you type the command to execute it rather than using your mouse. So instead of double-clicking on a folder to open it, you change to that folder using a typed command called cd, for example. So remember, when you're using the terminal, you want to use your keyboard and not the mouse, so don't use your mouse. So you might ask, what is a terminal? A terminal is a program that you use to access the files on a Linux or Unix system on the laptop or computer that's sitting right in front of you. I call that computer your local machine because it's local to you. Or access files on a supercomputer that's in a different remote location, and I call that a remote machine. You can access a terminal or on a Mac or a Windows machine, as I'll talk about here in a second. On a Mac, you can use the little finder, which is located in the upper right hand corner, and search for and open the terminal program. And then type in SSH, your username, at hostname, for example, ssh andrew.severin@series.scinet.science, or ssh severin@bridges.psc.edu. Then hit enter, and that will get you logged into your remote machine or your supercomputer. So let's go ahead and try that. I'm going to click on the Finder. Type in terminal. You can see it finds that program. I hit enter, and it brings up a new window. And then you can resize this window by holding down the apple and then hitting the plus button. And I want to make this large enough so that you guys can see as we're going through the tutorial. You can also resize the window like this. I'm going to put this on the right hand side here. Okay, now that we have this window, let's go ahead and log into that remote machine. I'm going to type SSH, my username, andrew.severin@series.scinet.science. Hit return. In this case, it has double authentication and therefore requires a verification code. I type that in. It will not show your typing while you're typing, so you type it in and you hit enter, and then asks for the password. Same thing, you won't see the typing when you're typing, but you are still entering your password. And now you're logged in. Similarly, on a Windows machine, if you click on the Windows icon and then start typing CMD for command. You can hit enter and the command prompt or terminal will show up on your machine, and then you can type in SSH, your username at your host name, and hit return, and that will also start the login process. I'm going to take a second now and talk about terminal terminology. So when you're working in a terminal, it's helpful to know some basic terms for when asking for help or describing a problem. When you first log in, you notice that the screen kind of scrolled a little bit, and all of that text is the welcome message. There is a prompt, which is this portion of the terminal, which is composed usually of your login name, so your net ID at the host name, and you enter commands on this prompt line. And this particular command is a list command, ls, and when you hit enter, it gives you output. That output is called standard out. In this case, we added a parameter to that ls command or list command, so list space -l gives long format and will give you information about the permissions of who can access the file, who owns the file, what group are they in, the file size, the date it was created, and whether or not that file is actually a link or pointer to another file. So that's standard out. Every time you hit enter, you get a standard out or a standard error message. If you type in a command that is not a valid command, you will get a not a valid command or command not found standard error. Okay, next section, getting started. Let us start by getting everybody logged in and at the same point. So if you haven't already, go ahead and SSH into your remote system. Once you are logged in, I want everybody to execute these three commands. Just go ahead and copy and paste these three commands into your terminal. What this does is it puts everybody in the exact same location and makes sure that the path of working directory command provides the same output regardless of what machine you are logged onto. In this first section, I'm going to go over 4 of the main commands. That's make directory, path of working directory, change directory, and list. And what this does, it'll make a directory, it'll tell you where you are in the file system, it'll allow you to navigate the file system with by changing directories, and it will list the contents of a folder. So the first command is make directory, and the first thing we're going to do is make a directory named Unix tutorial. So make directory, you type that in, make directory Unix tutorial. Now it will return the prompt again right here, and that means you did it right. If you get an error message, then it most likely means you forgot to put the space. So there has to be a space between the command and the argument, in this case the folder name. If you don't do that, it says command not found, because there is no make Unix tutorial command, there's a make directory command. If you've already made the directory and you try to do it again, it will also give you an error saying that a file already exists. The second command is path of working directory, pwd. Over in the tutorial here, you'll see that I show you where the commands come from. Make directory comes from the mk and dir. Path of working directory comes from pwd, so pwd. This tells you where you are currently. And so this, you can see that we are currently in our home directories, /home/andrew.severin. And we can change directories, say to the directory we just created, by using the cd command. So change directory, cd Unix tutorial. If we type pw again, you can see now we are one folder down in Unix tutorial. We can change back to the previous directory by going /home/our name, but that's kind of long. So let's change back into Unix tutorial. And the change back, you can also use 2 dots, ... So a single dot means this directory, a ... means the directory above the directory you're in. So let's try the following commands located here. And this will really give you some understanding of how these commands work and how you can navigate the file system. If you hit tab, it'll auto-complete for you. As you can see, as I'm going through this, the location of where you are gets lower and lower until you get to the final /, which is the root directory. Change directory by itself will take you back to your home directory. And as I mentioned before, if you hit tab, so I'm going to type Unix and then I hit tab, it will auto-complete the rest of the folder as long as everything beyond that is unique. The next section is file creation and editing. We'll be learning 3 commands: ls, nano, and vim, listed here. ls is list, which will list the contents of a directory. Nano and vim are file editors, but we're going to focus primarily on nano. So the ls command will show you the contents of a directory. We all should be in Unix tutorial, which is located in your home netid Unix tutorial. We created that in previous sections. And we have the ls command. Let's go and give that a try. Nothing happens. It returns a prompt. And that is because this folder is currently empty. So let's go ahead and use nano to create a file. Nano is a text editor. If we type nano, you can see that it acts just like you would expect a text editor to do. And I can delete all this stuff. At the bottom are functions that allow you to do things. So I can hit Control, which is that caret, G to get help. And this tells you all the different types of functions you can do within the nano text editor. To get out of this, we hit Control X, and if I want to exit, I hit Control X, and I don't want to save the buffer, so in this case I'm going to say no. If we type ls, we still do not have a file. Now, let's go ahead and create a file. We'll name it myfirstfile.txt. So nano myfirstfile.txt. And I'm just going to go ahead and copy and paste this text. Copy, paste. And as I said before, to save this, I hit Control X. This time I want to save it, so I'm going to hit Y for yes. And I'm going to write it to my first file, so that's good. I'm going to hit Enter. And now if I type ls, we see a file. Vim is similar. If I want to type vim my first file, it would open that, and I could navigate using the arrow keys. The only problem is that it is difficult to get out of if you've never used Vim before. So I hit, in order to get out, you hit Escape, and then you type colon, which you'll see at the bottom, and then quit or right quit if you made changes, and that will get you out. So that way you don't get stuck in Vim the first time you explore it. So again, those are the very basic usages Escape gets you out of, gets you back to the original state. I is the insert state. Escape :right quit will allow you to quit. If you want to know more about Vim, you can check out these 3 links here. Vim Adventures is it's a game that allows you to actually learn all of the tricks and commands within the Vim program to make you really efficient. It's a very powerful text editor. Okay, so this next section is viewing file contents. And it's really easy to remember the commands for viewing file contents as a cat has a head and a tail, more or less. So the commands are cat to catalog a file that will actually give you the full file contents. Head will show you the first few lines of a file. Tail will show you the last few lines of a file. More will view the file with less options. Less will view a file with more options. And seek is a command that will write a sequence of numbers out for you. First, let me show you what the seek command can do. So if we type in seek 1, 1, 10, it'll show you the first 10 numbers, 1 to 10. But what I really want to do is create a file with the first 100 numbers in it. So let's do a seek 1, 1, 100. And just like before, let's go ahead and copy the contents. And I'm going to type nano. Let's put this in a file named numseek.txt. Hit enter. Apple V, so I paste it in here, and Control X to exit. Yes, I want to save this. Numseek.txt is good. I'll hit return. If we type ls, we can now see there are 2 files. Perfect. So now we've created another file named numseek.txt that has 100 numbers in it. If we use cat, we can try catting that file. Numseek. We see it returns the entire file's content. If we do a head on the file, it'll give you the first 10 lines. And because there are numbers, we can actually show it's the first 10 lines. We can modify what head does, this command, using a parameter. When you use a parameter, you type in the command, you add a space, and in this case I want to show just the first 5 lines. That's the -n and the number of lines, 5. And I made a mistake here, so I'm going to hit Control C to cancel that. If I hit up, I can now put the file name numseek.txt, and if we do that, we can see that we have the first 5 lines. If I wanted to do the first 7 lines, I would just change that number. Same thing will be true for tail. Tail is the end of the file, the tail of the file. So tail-n2, numseek.txt. And now we get the last 2 numbers with the 2 lines. This is very useful when you're trying to grab just the header of a file, or the very last line of a file, or something in between. The more command is probably one of the commands that you'll use quite a bit, because you can type more numseek, and if you hit enter, it'll show you a screen's worth of numbers. So my screen has the ability to show me 59 lines. And that's only 57% of the file. So if I hit spacebar, it shows me another 57 or 59 lines. 59 lines. And then it exits me out into the prompt. If I use less, it will show me those 59 lines, but if I hit space, it shows me the rest of the file. But it doesn't actually exit me out of the less command. I can actually use the up and down arrow to move line by line up and down. I can use the U to go up a whole page, or spacebar to go all the way down. I can also use the D to go down. So page up, page down. Go ahead and give this a try. It's great. So less is fantastic when you want to really explore a file without quitting. I use more a lot just to show me the contents of a file, to see the beginning of the file. All these things are very useful, but this is how you actually look at files. So again, that sentence is, a cat has a head and a tail, more or less. In this section, we're going to cover renaming, copying, deleting files and directories. The commands I'm going to cover include touch, make directory, remove files, copy, and move. So the touch command allows us to very quickly generate empty files. So we type ls, we see that we just have our two files, my file, firstfile.txt and numseq.txt. If we wanted to create text files with names that are AA, BB, CC, 1, 2, and 3, we could do this by using the touch command, touch AA.txt, BB.txt, CC.txt, and touch 1, 2, and 3.txt. And now if we type ls, we see we now have all the files I just created using the touch command. We can also create several files simultaneously. So let's add a D, E, G, 4, 5, and 6. Now if we type ls, you can see I created all of these files all from a single line. They're all empty, but that's one way to create a file. If you want to create a folder, you can use make directory. Let's go ahead and create one named numbers. You can see there's the numbers directory, letters, there's the letters directory. I'll go ahead and create a delete me 2, and delete me 3 folder. There we are. Now we can create some files within them, because right now if you look, they're all empty. There's nothing in them. But we can create some within them by specifying the path. So let's create in delete me.txt, and another file called delete me1.txt, and you can see I'm actually specifying the folder and the file I want, because we currently are in here. I could also change to delete me. Well, in this case, let's go to delete me 2. And then I can just do a touch on delete me 2.txt, delete me 3.txt. We type ls, we see those two files. If we do ls ... for the parent directory, we can see all the files that were there. We can also go ls ... /delete me, and you can see that those are the first two files I made. So this is called the relative path. So we are currently here, and we want to look at one folder up and one folder back down, but a different folder than the one I'm in. So let's go ahead and change back, if you haven't already, to the Unix tutorial. And we will talk about deleting files and directories. Now I'm going to give you a warning that these commands are extremely powerful, and once you execute them, there is no getting the files back. There's no trash bin, there's no place to look for deleted files. They're gone. So if you delete a file, they're gone. The good news is it's impossible to delete anybody else's files that they haven't given you permission to delete. So if you create something, you own it, only you can delete it. Okay, so next command, remove directory. Let's see what's in our folder. Okay, so that's what's in our folder. To remove a directory, let's go ahead and remove directory, delete me 3. Hit enter. Nothing seemed to have happened, but if I hit ls, delete me 3 is now gone. Now if you recall, that folder was empty, and that's kind of important because if you tried to remove directory, delete me 2, it says directory is not empty. It's not possible to delete. And so the only way to do that is to use the remove command to remove all the files in the folder. So we could do that. Let's see, ls delete me has 2 files. ls delete me 2 has 2 files. So let's go ahead and remove delete me 2, delete me 3.txt. So I'm removing the file delete me 3.txt. If we type ls delete me 2, we see that we now only have this one file remaining. I'm going to type clear and take us back to the top of the screen. So what I would like you guys to do is to remove the delete me 2.txt file from the delete me 2 folder. So ls delete me 2 folder as one file. Use the remove command to delete that. You can confirm that by looking at the delete me 2 folder. It's empty. And now you can use the remove directory delete me 2. Now if you have hundreds of files in a folder, it can be extremely time consuming to remove all the files. So you can force a remove directory by using the remove command and a recursive parameter. So we type ls, we only have one more folder to delete. In it has 2 files. You can't delete it using the remove directory command. It says directory not empty. So I'm going to use the remove -r for recursive, delete me. It'll recursively delete all the files in the folder and then the folder itself. Now all the delete me folders are gone, and you've learned several ways to delete files and folders. Extremely powerful, extremely dangerous if you're not careful. Okay, move command. So we have all of these letter files and text files, number files, and we want to move all of those text files into their corresponding letters and number folders. So we can do that using the move command, mv, 1.txt to say numbers. We can also do it multiple files at a time. So 2.txt, 3.txt to numbers, or 4, 5, and 6 to numbers. If you're wondering how I'm typing that so quickly, I'm actually using the tab command because there's only a few files, and if you type in 4 and hit tab, it'll autocomplete for you. And as you can see, now we have just the letters. So your exercise now is to move all of those letters into the letters folder. When you're done, you'll know that you've succeeded by typing ls and only seeing two folders and myfirstfile.txt and numseq.txt. And if you look in letters, you should see A, B, C, D, E, and G.txt. Some of you may have realized that it's not in order. So we can fix that. So if we change to letters, type ls, we want gg.txt to be ff.txt. ff.txt. So we can move gg.txt to ff.txt. So the move command not only moves files between folders or directories, it can actually move a file from one name to another name. It's a renaming command as well. Now if we type ls, we see that they are in proper order. A, B, C, D, E, and F. I'm going to change back to the Unix tutorial. I'm going to change back to the Unix tutorial by going up one directory. The next command is copy. Let's go ahead and get a clear slate here. This command will copy files. So we type ls. We got two folders and 2 files that we could copy. Let's copy my first file to my second file. My second file.txt. We type ls, we see now we have a second file. We can confirm that it did copy it properly by using the cat function. We see text. We see identical text. So that seems to have worked just fine. We can also verify that it has the same number of bytes. So if we use ls, but we do a parameter that requires a space, -l for long format, and we do that on my first file and my second file, we see it gives you permissions, it gives you who owns it, what group they are in, and it will also tell you how many bytes there are. So 563 bytes in both of them. That suggests they're identical and they were created at slightly different times. May have done this too quickly. It didn't actually give you the time yet, but that will update. So if you want to copy a folder, you have to use a different parameter for copying. You have to do it recursively. So copy -r letters to letters copy. Type ls. We now see there's a letters copy. Letters. If we look at those folders specifically, we see they have the same files. Okay, I'm going to get a new screen by hitting clear. The next section we're going to look at is counting, sorting, and redirecting output. So up to this point, you have learned individual commands that roughly give you the same kind of ability as you did in Windows or using a Mac with iOS. And that doesn't really show you the power yet. But from this point on, you're going to start to understand why command line and why you'd want to use Unix commands to do data analysis. So in this section, we're going to cover word count, sort, unique, piping, which pipes it from one command to another command, translating, which is a find and replace for a single character, shuffle, which generates a random permutation of lines in a file. And that one's more for our particular use case here. And then pipes and redirects. So in this case, there is a way that we can put the content, the standard out from a function, either supply it to a command or take that output and put it to a file, or append it to a file, or do it between commands. So let's start out with word count. If we do, let's type ls so we see what we have. Okay, word count on numseek.txt. So if we do word count on numseek.txt, we see there are 100 lines, 100 words, and 292 characters. We can do that individually using number of lines using the parameter -l for numseek, word count for number of characters, word count number of words, and we get the same answers. Now we have to be a little careful because the -c for characters assumes that all the characters are single byte. In some languages, a character may be multiple bytes or require multiple bytes, and therefore you'd have to use the -m parameter. Okay, translate. This command can take any individual character and replace it with another character. So let's go ahead and translate the /n with commas for the numseek, and we can do that by redirecting the numseek file to this particular command. So when we do that, we get comma separated numbers rather than, I'll show you, line separated numbers. So again, what we've done here is we've taken all of the returns and replaced them with commas. This is the return, /n. We replaced it with a comma. And then this translate command happens to require that you supply it standard output. And so we can redirect the file's contents to this function. And that's a caret. We can also use a pipe command or a pipe redirect to do this. So pipe, if you haven't located it on your keyboard, it's located here where right above the return or the enter. You may have to hit shift. So what we can do is we can cat the numseek file. We can pipe it through translate from the returns to commas. And we get the same answer. We can also pipe it through head. It'll give you the first 10. Extremely powerful. The shuffle command, we can take and create a random shuffling of that numseek file. So for example, we can do shuffle numseek.txt. Let's go ahead and pipe that through head. We can just see the first 10 lines. We do that several times. They're all different. Let's go ahead and put that into a new file called numseek random.txt. I want lowercase actually, numseek random.txt. And that will give us the numseek 100 numbers, but they will be in a random order. See? If we repeat that, we shuffle the numseek.txt and we use a double caret, that redirects the standard output to the numseek random.txt file, but in this case it will append it to the end of the file. So now we do a word count on numseek random.txt. We see we have 200 lines. And you can explore this with the less or more commands. Go all the way down, up. So we have 200 lines in there. The reason I want this, and I want it to be out of order and shuffled, is because I'm going to show you the sort command. The sort command, we can type sort numseq random, and it will sort the file for you. Let's go ahead and pipe that through more. Now you see it sorts it, but it doesn't sort it by number. It sorts it by 1, 1, 1, 1, 0, 1, 0, 100. So it starts it from left to right with the 1, and then it proceeds to 2s and so forth. That's not how we want it sorted. Really, we want it sorted by number. So we do it by -n, sort -n, numerically, pipe it through head. We see that we have a better sorting. But before we do that, let's go ahead and add 1 times 10 to the minus 10 and 1 times 10 to the 10 to this file. So nano numseq random.txt. I'm at the top of the file. I'm going to type in 1e to the minus 10, 1e to the 10. I'm going to Control X to get out, save it. Okay. So now if we sort this, pipe it through more so we can see it, we see that 1e to the minus 10 is not the smallest, and 1e to the 10 is not the largest number. We have numerical sorting proper, but the general sort is not being sorted for scientific notation. To sort it for scientific notation, we have to use another parameter called G for general sort. So numseq random.txt. We pipe that through head. We see that we now have the 1e to the minus 10 at the top. We type it through tail. So I just hit up and then deleted. We pipe that through tail. We see 1e to the 10 is now the last number. So it is now properly sorted. The unique command. Now, if you recall, when we did and copied or catted those files twice and appended it to the same numseq random.txt file, there was twice the numbers. So how do we make them unique? So if we do a word count on the numseq.txt, random.txt, we get 202. If we try to do a unique on numseq random.txt and we pipe that through word count, we still get 202. So it doesn't seem like it's doing anything. And the reason is because they haven't been sorted. Word count or unique requires that they're sorted properly. So let's go ahead and do a sort. We'll do a general sort on the random seq, pipe that through unique, pipe that through word count for number of lines, and now we see we have 102. And that's because we added those two scientific notation ones. We can look at this by piping head, piping tail, and that's what you'd expect. You can also do a unique-c and it'll count it for you. So let's go ahead and take a look at that. Pipe that through head. Now you can see there's only one of the 1e to the minus 10, and there's 2 of every other number. And this first number represents the number of times it was seen, the number of lines, and the second number is that line. So here's a good little exercise. I want you to identify the 5 most used words in my first file.txt. And the hint I have here is use the cat, the translate, the sort, the unique, another sort perhaps, and a tail, and the pipe commands. And I'll go ahead and give you guys 5 or 10 minutes to figure that out. We cat the file first. We can see that if we pipe it through and we replace spaces with new lines, now we have every single word on a new line. We pipe that through sort. Now it's sorted. We pipe that through unique-c to count. And that's great, but now we need to find the top 5, so we pipe it through sort-n numerically. And the last 4 or 5 lines will give me the top 5. Pipe through tail-n 5, and those are the top 5 words. Technically, we probably have to go to 6. And this is why Unix and Unix command lines are so powerful, is that you can build up these one-liners that give you what you want, and you can look at the output at each step. So like this line itself might look very intimidating, but I built it up little bit by little bit. The next section is find and replace. I'm going to go over a searching function called grep, a streamline editing or find and replace function called sed, and 2 very important variables, star and question mark. So grep stands for global regular expression print, and it's a finding or searching for a pattern function. So if we type grep space my first file.txt, you will see there are 2 lines here. I'm going to expand here. You can pipe that through word count, 2 lines. If we wanted to look at the occurrences, we can modify that function by using the -o for occurrences of the word space in my first file, and it will print out each instance of the word space. That's good if you want to know how many times the word space was in the file. There's ignore case, there is invert matching, which is -v, count, and we can prefix the output with line number. So for example, we could grep space, grep-n space my first file, and it will tell me it was the 3rd and 7th line. We can also invert that and find every other line that doesn't include space. And it tells me that it's 1, 2, 4, 5, 6, and 7. Grep is great when you're looking for a particular gene or a particular name or word or something like that in your files. History gives you a history of recent commands. So I can look at, let's say, the last 5 commands. And I can look at the history of every command that I had that I put my first file and take the last 5 of those. We could look at everything here for history. We can grep with ignoring case my first, and we can look at the last 5 lines. Or we could also find the last ones where I use that my first file but does not include the word space. But included unique. And now you can see these are previous commands where we sorted and uniqued it. Now we have a question mark and star variables. The question mark and star variables can represent one or many characters. So we can, for example, undo everything we did with numbers and letters. So let's go ahead and move numbers star.txt to here, and now we can see that all those text files are there. We can move the letters star.txt to here. I misspelled that. /star.txt to here. And now we have the numbers and letters back in the main folder. Now if we want to repeat that, we can actually replicate what we did much more efficiently by using these two variables. The question mark represents a single character, so we can actually say ls question mark.txt, and that'll give me all the ones that have a single character.txt. If we wanted a two-character name, we could do it that way. So now that we know we can do that, we just move question mark.txt to numbers and move question mark.txt to letters. And that's because one question mark represents any character. And since these are always of the format two characters.txt, and this is always of the format one character.txt, we can execute these commands and efficiently move files around. So sed is a stream editor. It's a command that allows you to do a find and replace. So the way it works is you type the command sed, you tell it to do an operation. In this case, it'll be a substitution. We're going to replace galaxies, the word galaxies, with universes on that file. So if we type sed substitute galaxies with universes globally for every time we see it on my first file, we now see space travel between universes. Maybe we don't remember, so let's go ahead and grab galaxies from my first file. It's just that last line. But as you can see, it got replaced. If we wanted to do that in place, because right now the file hasn't been changed, we just put it out to standard output. We can actually give this a parameter -i to make this change in place. And now if we do a more on my first file, you can see it's been replaced with universes. In this section, we'll be talking about downloading and transferring data. How do you get data to the remote machine? How do you transfer it between your local and your remote machine? The three commands I'll be covering are wget, secure copy, and rsync. So wget downloads or gets a file or information from the World Wide Web. So let's make sure we are in Unix tutorial, and we can wget a couple images that I happen to have on the bioinformatics workbook. So go ahead and type wget and then paste that link. This is an image of a cat. As you can see, I went ahead and downloaded and saved it as cat.jpg, so JPEG. And we can see that here. We can do the same thing for an image of a salt and pepper shaker. And it's as easy as that. We have those two pictures copied to Unix tutorial. Now, the problem is that you can't more these files because they will mess up your terminal. So let's clear that. So how do we look at these images? Well, in theory, since they're from the web, you could just go to the website. But instead, if you needed to copy over data or you needed to copy it to your local machine, we can use another command called SCP, or secure copy. So we're going to need a new terminal. So if you click on the terminal, the black terminal, and you hit Apple New, or you open up another terminal, you can type SCP, in this case andrew.severin@series.scinet.science. And then we have to put in the folder. So I'm secure copying from the remote machine with my login, so Andrew Severin at the remote machine. And I need to know what directory we're in. So we are currently in home, Andrew.server, and Unix tutorial. So I will copy and paste that there. And I need to know the name of the file. Say cat.jpg. So / cat.jpg. I'm going to copy it to my downloads folder. It's asking for my verification code, which I can look up and give it. And it's asking for my password, so I'll give that. And there we are, it's transferred. So now what we could do is I could look up that file on my local machine, and you'll see a picture of a cat. And I can actually repeat the same process with the other JPEG, salt and pepper. So let's go ahead and delete cat.jpg and replace that with salt and pepper. Asks again for the verification code since it's double authentication, so I provide that. I give in my password. Oh, didn't accept that. Verification code. And password. And we can transfer that as well. And so if we look at the downloads folder, we can see there's a cat.jpg and a salt and pepper JPG. And once you have that downloaded, go ahead and look at them. Those images should look like this. And this. The other thing we can do is rsync. So if we want to, we can rsync an entire folder over. So using the same strategy, instead of SCP, we can actually rsync an entire folder. So I'm going to copy this whole path, and I'm going to type rsync-avz-e SSH. So I'm using the SSH protocol to transfer this folder from here to my downloads folder. I'm typing in my verification code for double authentication and my password. And when I do that, you can see I've transferred the entire contents of that folder. I can now go to downloads, Unix tutorial, and all that information is now on my local machine. In this section, we'll be talking about the Unix manual pages and soft links. The Unix manual, or man command, will give you access to the help manuals in Unix. So if you type in man ls, it'll give you all the information about the ls command or list command. You can see all your favorites are here, like -l. Use a long listing format. There's a -a for all. So that includes all the ones that start with dot, for example. And go ahead and do this for cat and more and less, and learn more about these commands. I'll go ahead and give you a few minutes to do that. And then when you're done, go ahead and continue this tutorial. The other command that I'm going to teach you is the link command, or ln command. So if we change to numbers, the numbers folder, we can soft link the my first file.txt, which is up one directory in this folder. So what is soft linking? That is a pointer to a file. So you didn't actually copy the file, but you can still look at it. If we do a long format, you can see that it's pointing to my first file.txt. Now, here's a special note here. If you can remove that file, which is actually a linker, without actually removing the my first file in the folder above. So remove my first file in the numbers folder. It's no longer there, but as you can see, it's still here in the main folder. So it will not affect the my first file in the Unix tutorial folder. If you have more questions about basic Unix, feel free to read more about the summary of Unix commands. This is a cheat sheet that was originally developed by Arun Sitharam, and it's a really great resource to find your favorite commands.